Hi there. In today's lesson, we're going to look at multiplying polynomials. So far, we've been focusing on factoring polynomials, and we can actually think of factoring as almost as a type of division. Instead, today we're going to kind of do the inverse of that. We're going to look at taking binomials and trinomials and multiplying them together. So I say here, consider the product of these two binomials. So that kind of wording, when we say product, we're talking about a multiplication. And the general idea when we do multiplying polynomials is we're just applying the distributive property. So in this example, if we take this first term of the binomial and multiply it by each term of the trinomial, and then we take the second term and do the same. So once we've done all this, we end up doing 6 multiplication operations. The next thing I ask you is, what if you multiplied trinomials together? How many multiplications would you have to do? So you can kind of imagine you'd have like, say A plus B plus C, multiplying it by another trinomial. And if we were to use the distributive property on this, we would 1, 2, 3, and then we'd probably go maybe like this. We go 1, 2, 3, and then finally 1, 2, 3. So we do 9 multiplication operations. This process, when we're taking the product of two binomials, this is expanding. So in this next box I say, okay, well, when we use the distributive property, that's expanding the expression. And there's 2 other things we can do after we expand an expression. We combine like terms and we order the variables, and that's what we call simplifying. So here's 2 examples. Here is when we combine like terms, so 3x squared minus 4x minus 7x plus 13. We combine these 2 terms because they're like terms. They both have the same order of variables, which is a single x. So this is that. So that's the type of simplification. The other kind of simplification we talk about is ordering the variables. So this is just generally good practice. So we look at each variable. So there's x cubed, there's an x squared, there's a single x. And we want to order them such that the biggest index, it comes first and gets smaller and smaller and smaller. So we go 7x3 plus 2x squared minus 3x plus 5. So we haven't done any arithmetic or any sort of operations on it. We've just put it in order, and that's another type of simplification. So here we can go through an example of expanding and simplifying. So first I'll multiply out the 3b term. So I get 3b times b squared plus 3b times 4b plus 3b times negative 1, plus 4b squared plus 16b minus, gotta be careful there, minus 4. So we expanded it out. Now I will gather like terms. So this is 3b cubed plus 12b squared, and then I'll take this guy here, so that's 4b squared, and then I go plus 16b minus 3b minus 4. So here we have some like terms that we can simplify. So this gives me 3b cubed plus 16b squared plus 13b minus 4. So that's taking this product of two binomials, expanding and simplifying it to give me the answer. Alright, let's do another example here. So we'll start off with multiplying out the x term. So x times 4x plus x times negative 7y plus x times negative 8 plus 3y times 4x plus 3y times negative 7y plus 3y times negative 8. So I have a 4x squared minus a 7xy. And then I'm looking ahead, I'm looking at this one, so that's a plus 12xy. And then I have a negative 8x, negative 21y squared, and a negative 24y. And I can simplify and order this a little bit better. So I'll go 4x squared minus 8x, minus 8x. I gathered these like terms, so I can add those together. So that's a plus 5xy, and then I have minus 21y squared minus 24y. So once again, I've taken the product of two polynomials, I expanded it, gathered like terms, and then put it in order and simplified it. Let's try another example. So this is looks to be a bigger expression. So here I think we just have to be more careful with our order of operations, essentially. And distributive property. If we keep track of these two things, we should be fine in simplifying this expression. So I'm going to go, I'll kind of do it in this order, I think. So I'll start off with 2d squared minus 12d minus 5d plus 30. So that's that part of it. And then maybe I'll do this one next. And I also have to be careful to keep track of this negative 3. We could also write this as 2d minus 5 d minus 6 plus negative 3 d plus 2 d minus 4. I think maybe thinking about it or writing it this way, it helps us keep track of the negative 3, because I'm gonna multiply all this out at the same time. So I'm going to start with here, let's kind of do it like this. So I'm going to go d times d is d squared times negative 3, so that's negative 3d squared. D times negative 4 times negative 3, that's a positive 12d. 2 times d times the negative 3 is negative 6d. And 2 times negative 4 is negative 8 times negative 3 is a positive 24. You could actually do this in multiple steps. You could think of it in terms of negative 3, sorry. You could do this in multiple steps. You could think of it as negative 3 times d squared minus 4d plus 2d minus 8, and then distribute it again. But here I chose to do it all in one step. So now let's gather like terms. I'll start with the d squared. So I have 2d squared minus 3d squared. I have 12d, I have a negative 5d, I have another 12d, well that's just by chance, minus 6d. Then I have a plus 30 and a plus 24. So these group together, those group all those group together, and these group together. So that gives me negative d squared. That cancels out, so that's a minus 5d and plus 54.